All right, so next thing we like to discuss about is the sample size determination, right? So following the same procedure like chapter 3, simple random sampling, under stratified random sampling, if we decided to perform or to conduct a survey, again, we need to determine what's the sample size. So suppose we specify the estimate y bar that should lie within the bounds of error b units of the population mean. So we set the probability of the absolute error, which is our estimate, to the true value. The absolute error is less than a bound of error, which could be approximately equal to 95%. Okay, so we set up this relationship, and under the standardization, we can say that the critical value multiplied to the standard error of my y bar is always less than equals to the bound of error. And from the previous lecture, we talked about how we derive the standard error of our y bar estimate under stratified random sampling. Okay, so it's like the estimated variance of y bar is equals to h of the stratum estimated variance adding up together, weighted by the population's weighting, but taking a square because we're looking at the variance. Okay, so take these or insert this into this standard error, which is taking a square root to that. Okay, so it looks a little bit complicated. So b, put it on the left hand side, greater equals to the critical value z multiply to the square root of the big chunked formula. Okay, and my objective is to relate n. So at the end, I want n, my sample size could be greater equals to something on the right hand side. Okay, so what I'm trying to do is perform some of the calculations, or not really a calculation, we just move around the equations so that we have n on one side and then the rest on the right hand side. Okay, so what we're trying to do is, first of all, we want to get rid of the square root, so take square on both sides. So we would have b squared divided by the critical values, taking a square, then we don't have the square root here. So again, we have the constant n squared, so move it to the right hand side. Okay, expand this two brackets. And then we know that NL is the stratum sample size. And we know that the weighting, little WL, is equals to NL divided by N. So in other words, we can replace NL by the sample size N multiplied to WL. Okay, so we just replace this. Now we have N on the bottom, and then we just want the rest of it to go to the right hand side. Okay, so what we do is we take out n, because this is not relying on the summation, so we take out n, 1 over n, and then we still have a bracket of the summation of NL squared as L squared divided by WL, and this thing is also a summation, it's within the summation. Okay, but we put it on the right hand side, so a minus to the right hand side becomes plus. Okay, now we have this whole thing divided by the summation, so move that to the right hand side. Okay, now we have 1 over n less than equals to this whole thing divided by the summation. We have n inverse, so we would have the summation divided by the whole thing plus the summation. Since we reverse, so we need to reverse the greater less than equals into the greater equals sign. Okay, now it looks good because formula 4.9, which is the sample size is bounded by the summation of something divided by n squared multiplied to d squared. Remember last time we said d squared is the error bound of is the bound of the standard error. Okay, so d squared was defined as b divided by the critical value square. Okay, and plus the summation of something. So I like equation 4.9. This is so clear. So we have the bound for our sample size. Again, if we look carefully into the sample size equation 4.9, we can compare the sample size determination formula with the simple random sample in chapter 3. So in chapter 3, what happened was that we only have one population and one sample. So there's only one stratum. So one stratum, that means L, capital L equals to 1. And the weighting W1 is also equals to 1. If we have one substitute to here, so we are having the same formula as we derive in chapter 3. Because in here you can see that it becomes n squared as L squared divided by 1. The n squared d squared plus, again, n as L squared. So we have n squared, and then we have n squared, we have n. So we cancel one n. Then we end up having n as y squared divided by, we cancel one of the n. So become n d squared. And there was one n that's been cancelled, so sy squared. So this is exactly in what we had in chapter 3. In chapter 3, 3.7 for the sample size determinations formula. Okay? But what we have in here is the sample size determination under the stratified random sampling. So we can see that the sample size, like the formula 4.9, the sample size very much depends again on the variability SL squared, or the variance within each of the stratum. The larger of the stratum, then we would have the larger of the sample size that we need to collect. And also, secondly, it depends on the bounds of error. The smaller of the boundary error, because it happens to be in the denominator, so the smaller of the bounds of error, the larger of the sample size. So if we can only accept a smaller bounds of error, we want to be more precise, then the sample size needs to be increased. All right, so it's very similar to how we did it in simple random sampling. All right, next thing, we'll just move on very quickly for the bound of error, if that is placed on the population total. So let's say if we were asked to estimate the tau total under stratified random sampling, and then we want to determine the sample size if we are given the bound of error that is on the population total. Okay, it is like the assignment questions. Assignment question number 3, that I want you to estimate the tau, the population total, and when we are asked to determine the sample size and we were given the bound of error B, that is on the population total. Okay, so we can do the same procedures, and then we have the variance of tau, which is n squared multiplied to variance of y bar. Okay, so after the same procedures like how we did above, we would be derived the formula for sample size determination based on the population total. N now is bounded by, again, the summation of each of the stratum and the variance methods. Now we have d squared. In this case, d squared would be the bound of error for the population total. divided by 1.96, of course, plus a summation of the variance of each of the stratum. Okay, so when we are dealing with the sample size questions, make sure that you know the given bound of error, whether this is placed on the population total or that was placed on the y bar, the mean value. Okay, because for the mean value and the total, that could have a different of the factor of n, so be careful. So there's no more capital N on top. The sample size determination equation 4.9 contains the estimate variance of y bar rather than the actual variance. So again, in this equations, that as L squared is on the variance of the y bar estimate. So I don't want you to be too confused. So the bound of error was placed on the tau, the total, but the SL, the variance, was actually on the estimated variance of the y bar. If the sample variance is not given, is not calculated, we can replace with the true value of the variance, sigma L squared. Again, sigma L squared could be obtained from the previous survey or some of the historic data or your estimates. Okay, so again, 4.10 was given for the sample size determination for the tau total, the population total. Okay. I will stop here and then we continue with the example.